Write linear models in context. So now we're going to use the information we have to write linear models, which we can then use to make predictions. So, a linear model, generally, we think of in the form of slope-intercept. So y equals mx plus b. You might have heard of this, where m represents the slope, b represents the y-intercept. Both of these can be either positive or negative, depending on pieces. So you'll see that we have a plus b, which is great, but it could also be y equals mx minus b if we have a negative y-intercept. Okay, so the other thing to discuss here is that we have x and y. So x and y represent an ordered pair, any ordered pair that fits on this line. So we think about a coordinate plane and we would graph the equation of y equals mx plus b. xy is literally any of these points. So this could be x1, y1. This could be x2, y2. This could be x3, y3. Those little numbers just representing this is my third ordered pair. That's it. That's all we have. So now let's go ahead and do this. Wait, let me back up. To write these equations, we need a slope, we need a y-intercept. Every equation will have an x and a y variable in them to represent every point on the line. So a new runner can run 0.5 miles without stopping, and each week added 0.15 miles to the distance. Write a linear model to represent the situation. So we need to identify the slope and the y-intercept. Now, if you forgot, which is possible, it's okay. Slope is the constant change. So the change that happens over and over, but it's always the same. That's the key. For the y-intercept, that's our starting point, or the initial value. So knowing that, let's go back to our question. A new runner can run 0.5 miles without stopping. Well, that's our starting point. That's how much we can run at the very beginning. The constant change, well, we're adding 1.15 miles to the distance each week. So constant change over time. So our slope is 0.15. So now that I know that, I can say, okay, well, if the general equation is y equals mx plus b, then let's go ahead and put in our m is 0.15, our b is 0.5, and this is positive. So we have y equals 0.15x plus 0.5. And that is our linear model. X represents the number of weeks, and y represents total miles. So I could say, like, after 6 weeks, then how much am I running? That kind of thing. All right, let's do another one. A jar of flour starts with 8 cups of flour. Each batch of dog treats made requires 1/2 cup of flour. Write a linear model to represent the situation. Okay, so once again, we're talking about slope and y-intercept. The slope is the constant change. The y-intercept is the starting point. Oh, just singular. Okay, so let's go through. A jar of flour starts with 8 cups. Well, if it starts with 8 cups, that is our starting point. So we know 8 is our y-intercept and our starting point. Then we look and we have a constant change of 1/2. But we're using 1/2 of flour, right? 1/2 cup of flour. So therefore it's going to be negative because every time I make a batch of dog treats, that flour goes away. So because it decreases, that is a negative. So when I go to write my, okay, so remember we have our y equals mx plus b. I can say, okay, I have y equals, my slope is negative 1/2, then I have x, and my y-intercept is a positive 8. So my linear model is y equals negative 1/2 x plus 8.